Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ukobela Maths. And without any further ado, let's look at this question that we have here. Okay, so we have question 8, still on financial maths. It says 8.1, a farmer bought a tractor for 980,000. The value of the tractor depreciates annually at a rate of 9.2% per annum on the reducing balance method. Note, then calculate the book value of the tractor after 7 years. Now, if we are looking for the book value, we are looking for A, right? Then we know the formula for reducing balance method is A is equals to P 1 minus I to the exponent of N, right? So the P will be the price or the cost of the tractor before depreciation, and then 1 minus the interest 9.2%, which we will have to first divide by 100, which will give us 0.092. And then the number of years, remember, it depreciates annually. So the N will just be the number of years, which is 7, right? So we are looking for the accumulated amount, which is our book value, the price or the amount of the tractor after depreciation, right? So when we punch that into our calculator, we have 498,685.82, right? Then for 3 marks, that's all we were supposed to do. Formula, substitution into the formula in the correct answer, right? Now let's move to 8.2. It says, how many years will it take for an amount of 75,000 to accrue to 116,253.50? Now, to accrue means to grow, right? To grow in an account earning interest of 6.8% per annum compounded quarterly, right? So for 8.2, we know that we have to use the compound formula. That is the formula used to just grow a lump sum without any regular installments, right? So we have our principal amount is 75,000, and then our accumulated amount, this is the amount that it grows to, 116,253.50, like that. Then we have 1 plus our interest here, 6.8% will be written as 0.068. But then remember, this is compounded quarterly. So if it's compounded quarterly, we must have over 4 because there are 4 quarters in a year. But then remember, we do not have the number of years. So obviously, we know the number of years here would be indicated by saying 4 multiplied by n, right? So the way we'll be representing that value here would be to multiply those number of years by 4, since it's compounded quarterly. So we have to indicate that here we have 4n. Now, if we divide both sides by 75,000, which is the first thing that we ought to do. So we already know that. Now dividing here, we will have 1.55. Let me just round off to 2 decimal places. Then this one, when we punch it into the calculator, so remember here, we'll just have these ones here dividing out. And then if we punch what's in the bracket into the calculator, we have 1.017, and then all to the exponent of 4n. Now we can just swap these ones here, 1.017 to the exponent of 4n. And then let's just bring the 1.55 to this side. So now we want to make 4n the subject of the formula. This will be 4n is equals to log base 1.017. And then up here, we will have 1.55, right? So you remember the log function that we use. It's that one there in your calculator. Now, when you punch that into your calculator, all of this, you get 25.998 and a whole lot of decimals there, which from here you can then divide both sides by 4 And then your N, if you round off to 2 decimal places, you get 6.50 years, right? So that means it would actually take 6.5 years to actually grow 75,000 to 116,253.50, right? So 6.5, that means 6 years and 6 months, right? So that's 6.5 years. So 6 years and 6 months. So, but then they only wanted that in terms of the number of years. So they said how many years? That's 6.5 years, 6.5 years. Okay, now 4 marks for that, 4 marks. Let's now proceed. Thabo wanted to save 450,000 as a deposit to buy a house on 30 June 2018. Wanted to do what? Save. So that's in the future. In the future, he expects to have a future value of 450,000. So now we know that we are working with a future value formula, whereby that 450,000 there will become our future value. Now, 8.3.1 says he deposited a fixed amount of money at the end of every month into an account earning interest of 8.35% per annum compounded month. His first deposit was made on 31 July 2013 and his 60th deposit on 30 June 2018, right? So note that. Calculate the amount he deposited monthly. Now, if you can check 31 July to 30 June, we can see that 2013 to 2018, how many years in between? So let's check. If we say 2018 minus 2013, we have 5 years, and then 5 years exactly, because it's starting from July to June. So that's exactly 5 years, right? And then how many months are in 5 years? We have to multiply by 12, and then 5 times 12, that will give us 60 months, right? So in total, he makes a 60 monthly deposit. So to calculate that 8.3.1, we'll say future value is equals to X, write the formula 1 plus I to the exponent of N minus 1 over I. Now we have everything that we need. So our X is, we are not told that that's what we are trying to calculate. Actually, calculate the amount he deposited monthly. So those are our regular payments. But then remember, future value, we said is the 450,000, right? So we have 450,000. The X here, that's what we are looking for. So that's 1 plus the interest, 8.35%. So that's 0.0835 over 12. And then to the exponent of 60 minus 1 over 0.0835 over 12, right? Now to calculate the X, we have already spoken about this. I said you take this one, cross multiply it with that, and then bring all this here to the denominator. So we have 450,000 cross multiplied with the 0.0835 over 12. Then all this here, bring it down as the denominator to divide that 0.0835 over 12, and then to the exponent of 60 minus 1. So you make sure that you have included all those brackets there exactly as they appear, because once you miss one bracket, it is possible that it might say a maths error, or you might just find a totally different answer. Then 6,068.89. So these are the monthly deposits that Thabo was making into the savings account. Okay, so that's how you were supposed to answer your 8.3.1. So that was only 3 marks. Formula substitution, correct answer. 8.3.2 says Thabo bought a house costing 1,500,000 and used his savings as the deposit. So note the deposit that he used is the savings, right? So he obtained a home loan for the balance of the purchase price at an interest. He obtained a home loan for what? For the balance. So that means it doesn't go to the bank and ask for 1,500,000, but he asked for the remaining balance after paying the 450,000. Now, if we wanted to find the value of what he obtains from the bank or the home loan is 1,500,000 minus 450,000, because remember, he's able to pay for that using his savings, right? So the value of the loan or the home loan is 1,050,000, right? From subtracting this. So this is what it goes to the bank and asks for, right? Then they say at an interest of 12% per annum compounded monthly over 25 years. He made his first monthly installment of 11,000 and 58.85 towards the loan on 31 July 2018. Now A says, what will the balance outstanding on the loan be on 30 June 2039, which is 21 years after the loan was granted? Now we are talking about what? Balance outstanding balance. Now with outstanding balance, we said we use the present value formula. So the outstanding balance for a loan, we're not taking it using that present value formula. But then all you have to understand with using the formula is that for N here, I will not be substituting the number of months in 21 years. In fact, I will have to substitute the number of months remaining in order for the loan to be paid off, right? So the 21 years means 21 years of payments have been made, right? So 21 years multiplied by 12, because remember, the payments are being made monthly. So obviously that will have to give us 21 times 12 is equals to 252. Now that means 252 payments have already been made, right? And then this loan must be covered over a period of 25 years. Now 25 multiplied by 12, that means all in all, the number of payments that needs to be made is 300, right? Now, if we're saying that he has already made 252 payments, but then all in all, we need 300 payments to be made in order for the loan to be paid off completely, then that means how many more payments does he have to cover? So that's 300 minus 252. And then that's how we get it, 48 months, right? Which we can also get by simply saying 25 minus 21, which will give us 4 years. And then we try to calculate the number of months in 4 years, which will be 4 times 12. Again, we can still find 48 months, right? So either way, you could have calculated that. But then what you need to understand with the N, as we have covered in the previous video, which I will drop a link. If you haven't checked it out, make sure that you check it out. So when using this channel here to watch the videos, please try to follow in terms of the way I post the videos. So I always indicate this is part 1, part 2, or episode 1, episode 2. So always try to follow in that order so that you understand, because most of the time what I did on the previous video will be what I continue with in the next video, right? So, okay. Now the X here, they told us that the monthly installments that are being made is the monthly installments of 11,058.85. So that's what we want to substitute there for X, 11,058.85. Now let's indicate that what we are trying to find here is actually the outstanding balance. Now we have 1 minus 1 plus 12% interest. So that's 0.12 over 12 compounded monthly. But then the n that we are substituting here, remember the number of months remaining for the loan to be paid off. So negative 48 over 0.12 over 12. So that's how we'll be finding the outstanding balance, right? So we find the outstanding balance by substituting here the number of months that are remaining for the loan to be completed, right? So now we find that if he has already made 252 payments in 21 years, then that means he will only be left with 419,948.32 to pay off from the loan value, or the value of the loan. So that's the money that is left off to pay from all of this money here, right? So I hope that makes sense. So this is not the money that is already paid. This is the money that is left off for the remaining 48 months. So understand that. Let's move to B. So for B, it says calculate the interest Thabo will have paid over the first 21 years of the loan. Over the first 21 years of the loan. Now, you will remember that we said interest is equals to n times x minus the present value, which we need to find the present value here. Now, to find the present value, remember I said this is what you need to consider. If this is T 252, which represents the 21 years, and then this is T 300, which represent the 25th year, then the outstanding balance that we had calculated was between the 21st year and the 25th year. So T52 and T300. So we found that the outstanding balance was 419,000, meant to say. So let's indicate it here, 419,948.32. But then we know the value of the loan from T0 all the way to T300. We know the value of the loan. We had been told here, we calculated, and then we found that it was 1,050,000. Right. Now, in order for us to find our PV, present value here, which indicates the amount that would have been paid in the first 21 years, then we only need to say this value here minus that value. So remember, in order to get the present value, that's the loan amount minus the outstanding balance. So we have 1,050,000 minus our outstanding balance of 419,948.32. Now, okay, having to punch that in our calculator, we get 630,051.68. Right. So this will be our present value here. So let's indicate it here. But in order for us to calculate the interest, remember this is the amount that needs to be paid off without any interest, right? Without any interest, if we are just considering that he needs to pay off the 1,050,000, this is the amount that we calculate. But then remember, the monthly installments are already given with interest. So now the bank has given him an amount of 11,058.85, which includes interest. This amount here, this month installment, includes interest. So to calculate that here, which is the NX, so let's calculate the amount paid, which is NX. Now, the N, how many payments will be made over the 21 years? that's 21 times 12, which is that 252. But then the monthly installments that is being made there, it's 11,058.85. Now the total amount that will be paid over the 21 years by Thabo is 2,786,830.20. So this is the total amount that Thabo pays over a period of 21 years. So note that if we now want the interest that is being paid, we need to take this amount that we found here minus the present value, right? So which will give us 2,786,830.20 minus the 630,051.68. Now we find that the interest is now equal to what? The interest is 2,156,778.52. So that's 2,156,778.52. So now you can see that the interest is almost like twice the amount that he actually borrows from the bank. So note that this is paid over a longer period. So that's 25 years. So it does make sense when you are old enough to buy your home, or maybe you can ask your parents if you are living in a bond and then they're paying that bond, you can ask the amount that they're paying and maybe ask to calculate the interest that they will be paying. You will see that these figures make sense, right? So I know a lot of you, when you are writing this type of questions, you get to question yourself if this is realistic. It is realistic in the real world. Yeah, realistic in the real world. Okay, so with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.